So picture, if you will, an ancient amphitheater.
Okay.
The air is just, it's thick with anticipation. You've got the scent of jasmine, dust, the intense heat of the Indian sun. And there's this hushed, almost suffocating silence from thousands of spectators.
Really setting the scene here.
Right. Because you, the listener, you are standing in the middle of this massive architectural marvel. And right in the center of the arena floor is this pristine, perfectly still pool of water.
But you're not looking at it to, like, admire the clarity or anything.
No, definitely not. Because high above you, suspended way up in the air, there's a complex mechanical contraption spinning rapidly.
Right.
And attached to it is a target, shaped like a fish.
Oh.
Now, you're an archer. You are holding a really heavy, highly tensioned bow. But here is the catch to this entire contest, and it's a seemingly impossible one.
You can't look up.
Exactly, you cannot look up. You have to string your bow, draw your arrow, and shoot straight upwards to hit the eye of that spinning fish, basing your entire aim, your timing, all your physics, solely on its reflection in the pool of water down below you.
Which is just, I mean, it's an incredible test of focus. And it is, for anyone familiar with the ancient texts, the legendary Draupadi Swayamvar.
Right.
It's from the ancient Indian epic, the Mahabharata. Historically, it's a story most people interpret as just this, incredible display of martial prowess.
A trick shot, basically.
Yeah, exactly. A tale of archery skill that borders on the magical, basically meant to establish the hero, Arjuna, as this warrior without equal.
That is the standard read. It's the ancient equivalent of, like, the ultimate trick shot to win the ultimate prize.
Mm.
But what if that conventional reading is just... What if it's entirely missing the point?
Oh, I love where this is going.
What if this famous mythological archery contest wasn't really about a guy who was just exceptionally gifted with a bow and arrow? What if it was actually this deeply coded, highly technical allegory for advanced cosmic navigation?
And that right there is the paradigm shift we're exploring in this deep dive today. We are taking this very specific piece of ancient myth, and we're going to subject it to the lens of modern astrophysics, orbital mechanics, and the ancient philosophy of cyclical time.
Yes.
Because when you strip away the mythological veneer, all the heroes and the drama, what you're left with is a highly sophisticated astronomical model.
Okay, let's unpack this. Our mission for this deep dive is ambitious, and it requires you, listening right now, to hold two completely different frameworks in your head simultaneously.
Right, mental gymnastics.
Exactly. We're going to decode Arjuna's arrow. We're going to explore this highly counterintuitive concept of, well, cosmic lag.
Cosmic lag, yes.
And ultimately, we are going to use the live math hidden in these sources to pinpoint the exact precise location of our solar system in the cosmos at this very moment, specifically the year 2026. We want to figure out exactly where our planetary vehicle is parked right now.
Which is wild, and the destination of this exploration is, I think, perhaps the most compelling part of all of this. Yeah, because by the end of this deep dive, you should have a clear understanding of a rather profound proposition. We're going to show how the macro mechanics of the spinning, massive universe out there mathematically mirror the micromechanics of your very own human lifespan.
Wow.
The proposition here in our source material is that the literal gears turning in deep space are fundamentally identical to the biological gears turning inside of you as you age.
That is a concept that forces you to reevaluate your entire relationship with time itself. So let's get into the actual mechanics of it.
Let's do it.
We have to start by contrasting two very different ways of observing the sky. On one hand, you have modern astronomy, right? We've got satellites, telescopes, laser telemetry, all of that.
The hard observable data.
Exactly.
Right.
And on the other hand, we have this ancient model presented by a philosopher and scholar named Surya Yukteswar. And this was largely codified in the late 19th century. But he's drawing on texts that are thousands of years older.
Right.
And the core of this debate, the friction point, centers around a specific astronomical phenomenon called axial precession.
Which is absolutely foundational to understanding everything we are about to discuss today. If you imagine the Earth as a spinning top on a table,
Okay, yeah.
you know that a top doesn't just spin perfectly vertically, right? As it spins, its axis slowly wobbles in this wider, slower circle.
Right, it kind of leans and traces a circle in the air.
Exactly. The Earth does exactly the same thing as it spins in space. It wobbles.
Uh,
The North Pole doesn't always point to the exact same spot in the stars, and modern astronomy has tracked and measured this wobble with incredible precision.
right. We can literally watch it happen.
We can. And according to our current instruments and observations, it takes the Earth roughly 25,920 years to complete one full cycle of this wobble, pointing back to exactly where it started.
So 25,920 years. That is the empirical data. It is what we can physically see, track, and measure today from our observatories. It's a visible, observable cycle.
That is the modern consensus, yes. But Sri Yukteswar's model introduces a significant complication to this.
Right, here we go.
He proposes a model of cyclical time, fundamentally known as the Yuga Cycle. And according to his synthesis of these ancient astronomical texts, the actual pure mechanical divine Yuga cycle of our solar system, meaning the true mechanical movement of our system as it travels up and down in its broader cosmic orbit,
Right.
is exactly 24,000 years long, not 25,920.
Wait, 24,000 exactly.
Exactly 24,000. It is defined as a 12,000 years in ascending motion, where it's gaining energy, and 12,000 years in descending motion, losing energy.
Okay, so we have a rather large discrepancy to deal with right away. Modern science sees and measures a cycle of 25,920 years.
Right.
But the ancient texts claim the true underlying cycle is a perfect 24,000 years. I mean, this isn't just a slight rounding error or like a bad translation. We are talking about a physical difference of nearly 2 millennia.
It's massive.
And this is exactly where the Draupadi Swayamvar analogy becomes highly functional, rather than just being a poetic myth.
It serves as the absolute perfect visual metaphor to explain why there is a discrepancy between what a modern telescope measures and what the ancient model claims. Think about the physical setup of that archery contest again.
Okay, you have the reflection of the spinning fish in the water down below.
Right.
In this analogy, that reflection in the pool represents the 25,920-year cycle. It is the visual data. It's what we observe from Earth. It's the shadow, basically, or the illusion of the object.
Exactly.
But the actual mechanical fish rotating high up above in the air, that represents the true 24,000-year cycle of the solar system. The hardware versus the reflection.
Which naturally forces us to ask, if the solar system's true mechanical orbit is 24,000 years, why do our highly advanced modern instruments measure a 25,920-year cycle?
Yeah, why is there a difference between what we see and the mechanical truth?
The text attributes this to the physics of light, time, and our observational perspective. It points toward concepts that we would recognize today as time dilation and light delay.
I think we need to linger on this for a second because human perception is deeply flawed when it comes to observing the night sky.
Very flawed.
When you look up at the stars, your brain immediately processes it as a live feed. You see the moon, you see Orion, and your instinct is, oh, that is what is happening right now in real time.
And that instinct is one of the most persistent illusions of human perception. You are never, under any circumstances, looking at the present moment when you look at the sky.
Never.
You are always looking deep into the past. Light has a strict speed limit, about 300,000 kilometers per second. It takes physical time for the visual data of the universe to travel across the incomprehensible emptiness of space, enter our atmosphere, and physically strike the retina of your eye.
It's traveling data.
Exactly. When you look at the sun, you are seeing it as it was 8 minutes ago. If the sun suddenly disappeared right now, we wouldn't know for 8 minutes.
Which is terrifying, but true.
Right. And when you look at the nearest star system, Alpha Centauri, you are seeing it as it was over 4 years ago. You are literally looking at a 4-year-old photograph.
So the visual data we rely on is fundamentally distorted by the time it takes to arrive here.
Precisely. Now, we need to scale that concept up to the massive sweeping movements of our entire solar system navigating through the galaxy over tens of thousands of years.
Okay.
The visible wobble we measure from Earth, that 25,920-year cycle, is distorted positional data. It is the reflection in the water. It is stretched and delayed by the complex relativity of observing a massive moving system from within that very moving system, compounded by the time it takes for cosmic positional data to be perceived from our specific shifting vantage point.
It's a visual artifact.
Yes, it's an illusion created by the physics of perception.
Which casts the story of Arjuna in a completely different light. If we follow this analogy, Arjuna's actual genius in that amphitheater wasn't just physical coordination.
No.
His genius was his ability to mentally calculate cosmic time lag. I mean, he didn't aim at the reflection in the water.
If he had shot at the reflection, his arrow would have passed through empty air because the reflection was delayed visual data.
Exactly. He looked at the 25,920-year illusion in the water, mentally calculated the mathematical offset of the delay, and shot his arrow where the mechanical fish actually was in the 24,000-year reality.
He pierced through the illusion of delayed perception. He aimed for the mechanical truth, not the visual shadow. He accounted for the lag.
Let's try to map this onto a modern experience so you, listening, can actually feel what this means. If you have ever played a fast-paced online multiplayer video game, you probably know all about server lag.
Oh, absolutely.
Right. Imagine you have a terrible internet connection, a really high ping. You are tracking an opponent running across your screen. If you aim your crosshairs exactly where their character model is on your monitor and pull the trigger, you will miss entirely.
You miss because the visual data on your screen is old.
Exactly.
By the time your action reaches the main server, that player has already moved several steps forward. What you are seeing on your screen is essentially a ghost image. It's an illusion created by the delay in data transfer.
To successfully hit that player, you have to lead your shot. You have to calculate the server lag in your head, actively ignore the visual data your screen is feeding you, and shoot into empty space where you anticipate the target is going to be when the data finally synchronizes.
Right.
In this interpretation, Arjuna was dealing with cosmic server lag. He was calculating the ping of the universe to bypass the distorted data.
That analogy holds up incredibly well. He understood that the visual feedback was compromised, so he relied on pure calculated mechanics. And recognizing this lag leads us to a rather fascinating mathematical puzzle in the source texts.
Yes, let's look at the numbers. You take the visible cycle, the illusion in the wire, which our telescopes measure at roughly 25,920 years.
Okay.
And you subtract the real mechanical cycle, the hardware in the air, which the text states is 24,000 years.
Right.
So 25,920 minus 24,000 leaves us with a very specific gap of exactly 1,920 years.
It is a massive chunk of time to simply lose in a calculation.
Exactly. So where do those years physically go? If the true cycle is 24,000 years, why does the universe's server lag stretch our Earth-gone perception by an extra 1,920 years? What is actually happening during that missing time?
Right.
The text offers an explanation that forces us to look downward into the absolute center of our own planet.
We have to address this 1,920-year discrepancy head-on. And the most crucial thing to understand here is that Sri Yukteswar's model does not treat this as a mathematical error. It's not a failure of observation.
It's deliberate.
It represents physical time spent doing something very specific and very violent. The concept revolves around the time required for cosmic gear shifting.
Cosmic gear shifting. I mean, we need to visualize what that actually entails on a planetary mechanical scale, because it sounds almost catastrophic.
Imagine the 24,000-year divine cycle as a massive pendulum or a giant wheel turning on an axis.
Yep.
For 12,000 years, the solar system is moving in one direction, ascending towards what the ancient texts call the Satya Yuga.
The Golden Age.
Exactly. This is described as a golden age of high energy, deep intellect, elevated consciousness. Then the system hits the absolute peak of that arc. And what must happen at a peak?
It has to change direction.
It has to change direction. It has to start its 12,000-year descent down toward the kaliyuga, which is the dark age of low energy and dense materialistic struggle. And once it hits the absolute bottom...
It has to reverse direction yet again.
Exactly. But planets and solar systems don't just stop on a dime. You can't just flip a switch and reverse the trajectory of celestial bodies.
It's not a video game.
No, it is not. And this is where the internal mechanics of the Earth itself become the limiting factor.
Yeah.
The Earth is not a solid, uniform rock.
Right.
Beneath the crust and the mantle, there is a churning liquid outer core, and deep inside that is a solid inner core composed of iron and nickel. This inner core is spinning with unimaginable momentum. When the solar system as a whole reaches the absolute peak of the Satya Yuga, or the absolute bottom of the Kali Yuga, the overarching cosmic directional shift occurs.
Macro shift.
Yes, but the Earth's inner core, due to its massive inertia, cannot simply shift its momentum overnight. It is physically impossible to instantly reverse a mass that large.
The inertia resisting that change would just be staggering.
It is. The text explicitly suggests that it takes a vast amount of time for the inner core to grind to a halt and then build up speed in the completely opposite direction.
Right.
According to this model, it takes exactly 960 years of immense planetary scale friction for this single reversal to complete.
Right. 960 years just to slow down, stop, and establish momentum in the other direction.
960 years of intense, sustained physical resistance. Now, because this reversal happens twice per complete 24,000-year cycle, once at the absolute top in the Golden Age and once at the absolute bottom in the Dark Age, you have two distinct periods of this planetary gear shifting.
Okay, so you do the basic arithmetic. 960 years at the top plus 960 years at the bottom.
Exactly.
And 960 plus 960.
Yeah.
That equals exactly 1,920 years.
There it is.
So that is where the time goes. That is the physical cause of the observational lag.
What's fascinating here is that the consequence of this friction is what creates the distortion we see in the sky. Because the Earth's core spends a total of 1,920 years per cycle, essentially stuck in transition, grinding against its own established momentum, the visual perspective from the surface of the Earth becomes desynchronized from the actual movement of the solar system.
The camera's shaking, basically.
Yes. Our observational platform is lagging behind the cosmic reality. The result is that everything we currently observe in the sky from Earth, the entire 25,920-year visible wobble measured by modern astronomy, is essentially a 1,920-year-old ghost image.
A ghost image, because we are looking out into the universe from a platform that lost 1,920 years to internal mechanical friction. Here's where it gets really interesting, because I want to spend a moment on this friction. It's hard to wrap your head around planetary mechanics.
It is.
So imagine driving a massive, incredibly heavy truck on the highway at 100 miles per hour. Suddenly, without touching the brakes, you grab the gear shift and slam the transmission straight into reverse.
The kinetic energy transfer would completely destroy the vehicle.
Right. The transmission doesn't just instantly flip and start driving the truck backward smoothly. There is a terrifying, grinding, violent delay. The gears scream, the tires smoke, the entire chassis shakes violently as the forward momentum fights the mechanical command to go backward.
It's a violent transition.
The truck has to bleed off all that forward kinetic energy entirely through violent destructive friction before it can even begin to move in reverse. That grinding delay, that terrifying physical stress on the vehicle, that is the equivalent of the 960-year planetary gear shift.
Now think about the physical and geological implications of that stress on our planet. We are talking about the core of the Earth acting as the transmission for our planetary vehicle.
Yeah.
During those 960-year reversal periods, as the Earth bleeds off momentum, the stress on the magnetosphere, on the tectonic plates, on the very structural integrity of the mantle and crust must be profound.
I mean, volcanoes, earthquakes.
Exactly. We are talking about potential periods of extreme geological upheaval simply caused by the planet fighting its own inertia.
Which totally makes sense of why ancient cultures might have mythologized this. I mean, a 960-year period of planetary instability would certainly leave a mark on human memory, probably recorded as cataclysms, global floods, or era-ending destruction.
Almost certainly.
But here's why understanding this 1,920-year mechanical lag is so crucial for us today. If we know exactly how and when these planetary gears shift, we theoretically hold the key to unlocking our current timeline.
Yes, we do.
If we know the mechanics of the planetary vehicle and how much time it loses to friction, can we calculate exactly where we are parked right now?
We absolutely can. And this is where the source material transitions from abstract philosophical cosmology into rigorous step-by-step chronological arithmetic.
I'm ready.
We are moving from theory to application.
This is what we promised at the start of this deep dive. We're going to do the live astromath to find our exact cosmic location.
Yeah.
And we're going to use our present year, 2026, as our anchor point.
Terrific.
I want to walk through this slowly because I want you listening to follow the logic and see how these numbers interact.
All right, so to map any cycle, you need a baseline. Step one is identifying the 0 point. According to the exhaustive calculations laid out by Surya Siddhanta, the absolute lowest point of the kaliyuga, the darkest, most dense, lowest energy point in the entire 24,000-year cycle, occurred in the year 498 AD.
498 AD. Okay, let's pause and look at what was actually happening on Earth around that time, because calling it a cosmic bottom implies something tangible about human civilization.
It does.
Historically, the late 5th and early 6th centuries aligned remarkably well with a global depression in human organization and knowledge.
Yep.
I mean, in Europe, the Western Roman Empire has completely collapsed by 476 AD. The aqueducts are failing, literacy is plummeting, and the continent is plunging into what we literally still call the Dark Ages.
And it wasn't isolated to Europe either. While there are always, regional variations, you see massive instability globally around this exact time.
Really? Like where?
In India, the golden age of the Gupta Empire is crumbling under invasions. In Mesoamerica, major centers like Teotihuacan begin experiencing internal strife and eventual collapse not long after.
Wow.
Globally, it represents a nadir in collective human infrastructure, philosophical output, and societal cohesion. It subjectively and objectively feels like a dark age.
So 498 AD is the moment the massive planetary gear finally finished its 960 years of reverse grinding. It hit rock bottom, the friction ended, and the solar system began its upward ascending journey.
Right, and this upward journey is referred to in the text as the Uttarayana.
Okay, so that locks in step 1. 498 AD is the absolute bottom of the curve. Step 2 is calculating when that specific dark age, the kaliyuga, actually ends. Because hitting the bottom of a pit doesn't mean you're instantly out of it.
No, you still have to climb out.
Right. And according to this ancient system, the total duration of the kaliyuga is exactly 1,200 years.
It's 1,200 years on the way down and 1,200 years on the way up. Since we are calculating from the 0 point at the absolute bottom, we're only looking at the 1,200-year upward climb to escape the gravity of the kaliyuga.
Got it.
The math here is incredibly straightforward. We take our absolute 0 point 498 AD, and we add the 1,200-year duration of the ascending kaliyuga.
Okay, so 498 plus 1,200. That equals the year 1698 AD.
1698 AD.
1598 AD. That year acts as a major boundary line. It marks the absolute death of the Kali Yuga and the birth of the next ascending age, the Dwapara Yuga.
Right.
And again, if we look at history, the late 17th century represents an absolute explosion in human consciousness. We were right on the cusp of the 18th century. The scientific revolution has taken hold. Isaac Newton has recently published his laws of motion and universal gravitation.
The Enlightenment is brewing.
Exactly. Humanity is suddenly waking up. We're discovering the principles of electricity, mastering the physics of the natural world, expanding global communication. It really looks like human civilization crossed a tangible threshold into a higher energy age of intellect and discovery.
The historical correlation to a shift in human capability is striking. But to find our exact present location, we move to step 3.
Step 3. Find out where we are today. So we know the new age, the Dwapara Yuga, started in 1698. We are currently sitting in the year 2026. So we subtract the start year of the era from our current year, 2026 minus 1698.
Which leaves us with 328.
328, that is the conclusion of the chronological math. We are officially in the 328th year of the Uttarayana Dwapara Yuga. We are in the ascending age of energy, space manipulation, and intellect.
It is essential to contextualize that number because 328 years sounds like a long time to a human, but it is nothing on a cosmic scale.
It's a blip.
Exactly. The Dwapara Yuga is a 2,400-year era. It is twice as long as the Kali Yuga. So being in year 328 means we are still in the very, very early foundational stages of this new ascending age.
We're barely past the prologue.
We are essentially toddlers in the Dwapara Yuga.
Which forces a massive psychological shift for me. I mean, think about the pervasive modern narrative. So much of our cultural anxiety, our media, our geopolitical outlook is built on this underlying dread that we are in a state of terminal decline.
Oh, the doom scrolling.
Yeah, that things are getting worse, that civilization is collapsing, that we are spiraling down into a permanent dark age. But this ancient model completely inverts that script.
It fundamentally alters the framework. It shifts the mindset from one of inevitable terminal doom to one of realizing that humanity has actually been climbing upward out of the dark for over 3 centuries.
It's a totally different perspective.
It suggests that the chaos, warfare, and rapid technological disruption we see in the world today might not be the collapse of civilization, but rather the messy, turbulent, dangerous growing pains of an adolescent species trying to figure out how to handle the massive influx of new intellectual and technological energy that defines the Dwapara Yuga.
It's the difference between falling into a bottomless pit and tripping while walking up a steep mountain path. I mean, both hurt, both are dangerous, but the trajectory is entirely different. One leads to darkness, the other leads to the summit.
Exactly.
It is a beautiful, hopeful framework, and Sri Yukteswar's historical math is incredibly neat. But I have to push back here. It's my job to be the skeptical learner.
And skepticism is vital. What is the friction point for you?
The friction point is that anyone can build a neat mathematical model in a vacuum. It is a fascinating historical and philosophical exercise. But does modern empirical data actually support a seemingly random anchor date like 498 AD?
Ah, okay.
Like, if we ignore the ancient texts completely, can modern astrophysics, using completely different tools, corroborate that we are in year 328 of some cycle? Because if this relies purely on taking Sri Yukteswar's word for it, it remains a myth. It remains theology, not science.
That is the exact right question to ask, and it is where this source material elevates from a fascinating mythological curiosity to a genuinely staggering convergence of ancient wisdom and modern data.
Okay, lay it on me.
We are going to pivot right now away from ancient chronology and look exclusively at modern scientific wobble data, the precession of the equinoxes. I will show you how the modern observations align flawlessly with the ancient arithmetic.
Okay, let's reset. We're doing a second round of math, completely independent from the historical dates, relying on astronomical measurement.
Yes. We will use the modern scientific formulas regarding Earth's axial wobble to verify that Dwapara 328 calculation.
Fact number 1. We established the absolute 0 point, the bottom of the cycle, is 498 AD. Let's calculate the raw elapsed time. From that absolute bottom point in 498 AD to today, the year 2026, how many total years have elapsed? So 2026 minus 498 is exactly 1,528 years. Keep that number locked in your head. 1,528 years of total travel time since the bottom of the curve.
Now for fact number 2, which comes straight from modern astronomical observation, modern science has meticulously observed and calculated the speed of axial precession. It takes the Earth approximately 72 years to shift exactly 1 degree in its wobble against the backdrop of the zodiac.
Right.
72 years of time for 1 degree of spatial movement.
So we have our elapsed time, 1,528 years, and we have our modern speed metric, 72 years per degree. Let's see how far this guy's actually moved. We take the total elapsed years, 1,528, and we divide it by the speed of the shift, which is 72. So 1,528 divided by 72 equals 21.22.
21.22 degrees. This means that if an astronomer looked at the exact position of the stars in 498 AD and a modern astronomer looks at them tonight in 2026, the entire celestial sphere has demonstrably shifted by exactly 21.22 degrees in our observational sky.
That is a hard, measurable fact of physics.
Yes, it is.
But wait, can you just apply that entire 21.22 degrees to our current era, right? Because a huge chunk of that physical movement happened while the Earth was still trapped in the Dark Age, the kaliyuga.
Right.
We want to find out how far into the Dwapara Yuga we are. So we have to subtract the portion of the sky that belongs to the previous age. How much of that sky belongs to the kaliyuga?
We use the exact same modern metric to find out. We know the kaliyuga lasts 1,200 years. So 1,200 years divided by the modern observation of 72 years per degree.
Okay, 1,200 divided by 72 equals exactly 16.66 degrees.
Perfect. So the kaliyuga occupies 16.66 degrees of the sky. Now for the moment of truth.
Here we go.
We take the total degrees the sky has shifted since the 498 AD 0 point, which we calculated as 21.22 degrees.
Yeah.
And we subtract the kaliyuga's portion, which is 16.66 degrees.
Okay, 21.22 minus 16.66 equals exactly 4.56 degrees.
4.56 degrees. This specific number represents exactly how many degrees into the new Dwapara Yuga our planet has physically moved, according to modern observable data.
And here is the final validation. We know we have traveled 4.56 degrees into the new age. We know that modern science dictates every single degree takes 72 years to traverse.
Yep.
We multiply our remaining 4.56 degrees by the 72-year speed metric. 4.56 times 72 equals exactly 328. 328.32 to be precise.
It puts us squarely, undeniably, in the 328th year.
That is, I mean, it's actually a bit unsettling when you realize the math lines up that perfectly. Think about the implications of what we just did. We used two fundamentally incompatible methods.
Right.
Method 1 was straight ancient chronology, adding fixed dogmatic historical years from a 19th century text synthesizing ancient scripture. Method 2 was using modern astrophysics, calculating spatial angles and modern precession speeds. And both of them yield the exact same integer, 328.
It is far beyond the realm of coincidence. It is a mathematical validation of the ancient mechanical model. It suggests that the authors of these texts, whoever they were weren't just guessing, and they weren't just speaking in religious metaphor.
You actually knew.
They intimately understood the deep long-term mechanics of the solar system's movement, and they understood it with a precision that rivals our own today.
It's like two teams digging a tunnel from completely opposite sides of a massive mountain.
I like that analogy.
Right. One team is on the east side using ancient Sanskrit texts, astrolabes, and philosophical cyclical models. The other team is on the west side using modern astrophysics, laser rangefinders, and satellite telemetry. And they dig for miles, and they meet perfectly in the exact center of the mountain with zero deviation.
That doesn't happen by accident.
No. It means they were both working off the same fundamental architectural blueprint of reality.
The convergence of ancient cyclical time and modern observable precession is flawless in this specific calculation. But it begs a massive question regarding the origins of this knowledge.
Yeah.
If they didn't have modern telescopes, how did they know?
That is the real mystery, isn't it? Were they utilizing advanced lost technology, or was this the result of purely mathematical extrapolation based on thousands of years of naked-eye generational astronomy? Tracking a 72-year 1-degree shift requires an observational record spanning centuries just to notice a pattern.
It implies a civilization dedicated to long-term astronomical bookkeeping, passing precise measurements down through generations, long enough to chart a 24,000-year cycle. But as precise as this 72-year metric is for our current era, the text introduces a vital complication.
Right, because if I look at my notes, there's a potential flaw in the model we just built.
Yeah.
We just treated that 72-year per degree metric as a constant universal speed limit.
We did.
We used it to calculate the exact degree shift, assuming the Earth always takes 72 years to wobble 1 degree, no matter where it is in the cycle. But if we go back to our earlier spinning top analogy, does a spinning top wobble at the exact same speed its entire rotation?
It does not.
I've watched the top spin on a table. As it loses momentum, the wobble gets faster, wider, and much more erratic. Does planetary precession really have a constant speed over 24,000 years?
It is a critical observation, and it brings us to the most complex physics discussed in the source material. You are entirely correct. The 72-year per degree speed is not a constant, it is dynamic. It fluctuates violently depending on where the solar system is in its orbit.
So the math we just did works perfectly for our current localized slice of time. But the underlying mechanics over the whole 24,000 years are variable.
Exactly. The text introduces a concept of time acceleration based on a specific mathematical ratio. It's a 1.2.4.8 acceleration model. The speed of the Earth's wobble and the speed of the solar system itself changes drastically depending on its proximity to the gravitational center of its orbit.
But wait, if the speed isn't a constant 72 years, what was it in the past? Was it spinning faster during the Dark Ages or slower?
Let's look at the descent into the deepest part of the Dark Age. The text notes that around the year 4000 BCE, the solar system was rapidly plunging downward into the densest, most gravitationally intense parts of the descending kaliyuga.
Okay.
During the steep descent, massive gravitational forces were exerted on the system. Because of these forces, the Earth experienced a hyperfast wobble. It wasn't taking 72 years to shift 1 degree. The text states it was whipping around at a speed of just 45 years per degree.
45 years per degree. That is a massive acceleration compared to today. That means ancient astronomers observing the night sky in 4000 BCE would see the constellations migrating across the horizon at a highly accelerated rate compared to what we observe in 2026.
Yes, and the acceleration isn't limited to the Earth's axial wobble. The text makes a staggering, highly specific claim about the sun's own traveling speed through deep space. It states that the entire solar system's velocity varies drastically depending on the yuga.
Wait, the sun itself speeds up and slows down as it travels through the galaxy?
According to this ancient model, yes. It moves at its absolute slowest during the peak of the Satya Yuga, the golden age at the very top of the cycle. At that peak, the solar system is essentially coasting at approximately 207,000 kilometers per hour.
Okay, 207,000 kilometers per hour at the apex. What happens when it hits the bottom?
At the absolute bottom of the Kali Yuga, when the solar system is essentially falling inward toward the gravitational center of its grand orbit, it reaches a terrifying maximum speed of approximately 1,656,000 kilometers per hour.
Over 1.6 million kilometers per hour. It is literally falling into the dark age at maximum velocity, propelled by gravity, and then slowly coasting outward, fighting gravity into the golden age.
Yes.
This is where ancient texts sound exactly like modern physics. What they're describing is basic orbital mechanics. Johannes Kepler proved this in the 17th century with his laws of planetary motion.
Exactly right.
When an object in an elliptical orbit gets closer to its center of gravity, the periapsis, it speeds up significantly. When it moves further away to the apoaxis, it slows down. The ancient text is describing a highly elliptical eccentric orbit for our entire solar system around some unknown gravitational center, perfectly mirroring Kepler's laws thousands of years before Kepler existed.
They were describing orbital mechanics, gravitational acceleration, and variable precession, but they wrapped it in the spiritual and philosophical language of the Yugas. However, if we connect this to the broader philosophical purpose of the text, the absolute grand finale isn't just about the massive scale of the cosmos. It's not just about how fast the sun moves. It's about how that massive scale maps perfectly onto you, the individual.
This is where we bring it all home.
Yeah.
We need to talk about fractal geometry, or what the text refers to conceptually as the sacred spiral.
We've been heavily utilizing this 72-year metric, 72 years for the Earth to wobble 1 degree in our current era. What is truly profound here is that this 72-year metric is not just a random astronomical baseline. It is the exact blueprint for a standard, ideal human lifespan.
The 72-year life.
And just as the massive 24,000-year grand cosmic cycle is divided into 4 distinct yugas of different proportions, this 72-year human lifespan is divided into miniature ages.
Miniature ages in a human life.
The text refers to it as a micro-yuga, a microcycle of 4 ages, perfectly contained within a single biological human life. And it follows the exact same mathematical ratio as the macro ages in space, a 4.3.2.1 ratio.
Let's take the time to break this down because it fundamentally reframes how we view getting older. Let's look at the 72-year human life through this 4.3.2.1 cosmic code. The first age is the Satya Yuga, the golden age.
Right.
On the cosmic scale, it's the longest era, making up 4 parts of the total cycle. In a human life, 4 parts of a 72-year cycle equates to exactly the first 28.8 years of life.
From birth to roughly age 29, this is your biological Satya Yuga. It is the era of supreme, effortless growth, physical development, peak vitality, and rapid learning. It is the golden age of youth, where the body and mind are expanding at their absolute most rapid rate, unburdened by decline.
Then we move to the second age, the Treta Yuga. This makes up 3 parts of the cycle. In our biological math, that represents the next 21.6 years of life, taking us roughly from age 29 to age 50.
The Treta Yuga in the cosmic sense is the age of action, of building, and of struggle. Biologically and psychologically, this aligns perfectly with human adulthood.
It really does.
These are the decades where you're out in the world, building a career, raising a family, accumulating resources, and dealing with the massive stress and friction of societal responsibilities. It is the era of intense, sustained action and profound struggle.
Next is the Dwapara Yuga, which gets 2 parts of the cycle. That is the next 14.4 years, taking us from age 50 to roughly age 64.
The cosmic Dwapara Yuga is characterized by an understanding of energy, but also of physical heaviness. In a human life, this is the time when physical decline begins to become truly noticeable, the heaviness sets in. But it is also the era of true maturity, insight, and wisdom.
The golden years, in a way.
You realize you cannot rely purely on the boundless physical energy of your Satya Yuga youth anymore, so you must rely on efficiency and intellect.
And finally, the Kali Yuga, the Dark Age. It is 1 part of the cycle, the final 7.2 years of the 72-year lifespan, taking us from roughly age 64 to 71 or 72.
The era of decline. The biological systems begin to shut down. The physical body reaches its absolute limit, preparing for the inevitable end of the cycle death, which then resets the wheel for whatever comes next, much like the cosmic cycle resets at the bottom of 498 AD.
Think about the philosophical weight of this model. You can zoom all the way out, past the planets, out to the edge of the galaxy, and you see massive, incomprehensible cosmic gears turning over tens of thousands of years in deep space.
Mind-boggling scale.
And then you zoom all the way in, past the atmosphere, into the biology of a single human being, maybe you sitting in traffic right now, listening to this, operating on this exact same clock.
It's the exact same mathematical code.
The 4.3.2.1 ratio is written on the gears of your heart, your cells, your lifespan. The doctrine is literal, as above, so below.
It suggests an interconnectedness that goes far beyond poetic metaphor. It suggests a literal mechanical resonance between the macrocosm of the universe and the microcosm of biology.
It's the ultimate set of Russian nesting dolls. It's a fractal pattern. If you look at a fern leaf in the forest, the tiny leaves on the edge look exactly like the shape of the entire massive branch. If you look at a snowflake under a microscope, The microscopic branches mirror the entire crystalline structure. The universe, according to Surya Yukteswar in these ancient texts, is the time fractal. You zoom out to the 24,000-year divine cycle, or you zoom into a single 72-year human life, and the same blueprint is playing out, gear for gear.
And that blueprint gives order, structure, and meaning to both the seemingly random scattering of stars in the sky and the often chaotic phases of our own lives. It removes the randomness entirely.
We have covered a massive amount of conceptual ground today, and I want to synthesize the journey we just took. We started in an ancient amphitheater with Arjuna, exploring the idea that his legendary shot was actually the complex calculation of a 1,920-year cosmic lag caused by the violent grinding friction of a planet shifting its gears.
Right.
From there, we mapped the timeline, discovering that we are not trapped in a dying dark age, but are actively climbing upward in the 328th year of the ascending Dwapara Yuga.
We then took that ancient text-based calculation and verified it using the strict modern astronomical data of a 72-year planetary wobble. Two completely different fields of human endeavor arriving at the precise, identical integer of 328.
And finally, we brought all those stars and planets right down into our own biology, exploring how our 72-year human lives are miniature solar systems, taking to the exact same 4.3.2.1 rhythm of growth, struggle, heaviness, and decline.
As we close this deep dive, there is one final implication to mull over, building directly on the mechanics we've explored today.
Oh, I'm ready.
We spent a significant amount of time discussing the 960 years of violent, grinding friction that the Earth's inner core must endure just to shift the direction of a cosmic era. It is a period of massive instability.
Yeah, the gears screaming in reverse.
Exactly. If the macro truly mirrors the micro, if the Earth's core must grind and shudder to change eras, what kind of friction do we experience in our own human micro-yugas? When we transition from our biological era of golden growth in our late 20s, our Sati Yuga, into our era of intense struggle and responsibility in our 30s, our Treta Yuga, what does that friction feel like to the individual?
That is a staggering thought. Are the psychological crises we experience in life, our quarter-life and midlife crises, our profound growing pains, are they simply the friction of our own inner cores violently reversing direction to accommodate the new age of our biology?
It's something to think about.
You will have to look at your own transitions to decide that for yourself. We want to warmly thank you for joining us on this incredibly complex, mathematically dense, and philosophically profound deep dive. Next time you look at a reflection in a pool of water, remember that you might just be looking at the delayed shadow of a much grander reality. Until next time.